sketch the graph of the piecewise function and then evaluate the limit. So the first piecewise function, we have f of x equals to x0 negative x plus 2. So first of all, I would like to graph the second piece first. So when x is equals to 1, y is equals to 0. So that is a solid point. X is equals to 1, y is equals to 0. So that is a point right over here. And then the next one, I would like to graph the less than 1. So when x is less than 1, we have a x, so which is a straight line linear function. The slope is equals to 1. The function is going uphill from left to right. And then, so when x is equals to 1, y is equals to 1, but we have x less than 1. Less than 1 means you cannot put a solid point right there. So what happens if you put a solid point right there? That is not a function anymore because that will not pass the vertical line test. So the correct way to do it is you use an open circle and then draw a line that has slope past the 1. So this is a slope past the 1. So this is x. And then negative x plus 2 when x is less than 1. When x is greater than 1, so we have a negative 1, right? So we will have a negative 1 plus 2 that is equals to 1. And then, so looks like we have a line right over here. So the slope is equals to negative 1. All right. And then this is negative x plus 2. Okay, what happened when x approaches to 1? So as x approaches to 1 from the left, what happened? Y approaches to 1 or nothing. Y approaches to 1, right? And then what happened as x approaches to 1 from the right? Y approaches to 1. You might ask me, hey, when x is equals to 1, y is not equal to 1 because you have an open circle, right? This 1 comma 1 doesn't exist because we have an open circle. So when x is equals to 1, y is equals to 0. So we do not have the solid point where the two lines intersect at 1 comma 1. So what happened? Is the limit equals to 1 or the limit is nothing? The answer is the limit is equals to 1. The reason is I am asking for x approaches to 1. I am not asking x equals to 1, y equals to 1. X approaches to 1. So when x is equals to 1, you want to do a function evaluation, you only get a 1 comma 0. All right, but when x approaches to 1, the limit exists. So in the second example, I want to show you another one because like I want to show you what happens if you do not have any graphing paper. So if you do not have any graphing paper, that won't make the job super hard. So I will do the second piece first. When x is equals to 1, y is equals to 4. So we have a point when x is equals to 1, y is equals to 4, and then that is a solid point. And then I will do the first piece when x is less than 1, y is equals to what? Negative 2, and then put in 1 to it, and then you add 4, so that is negative 2 plus 4, then you get a 2. So when x is equals to 1, y is equals to 2. But you have x less than 1, so you do not use an solid circle, because if you do, that would not pass the what? That would not pass the vertical line test. And then decreasing from left to right, so the line looks like this. Don't forget that you have a plus 4. The plus 4 is a y-intercept, so you have a line that looks like this. And then the last one is a parabola, right? X squared plus 1. So x squared plus 1 is a parabola that the vertex is shift 1 unit up. Okay, so you have x plus 1, x squared plus 1. So when x is equals to 1, you have 1 squared plus 1. That is equals to 2. So when x is equals to 1, the point starts at 2. So you have a curve like this. All right. So now what happened when x approaches to 1? So as x approaches to 1 from the left, as x approaches to 1 from the right. So from the left hand side, we have y approaches to 2. Right hand side, we also have y approaches to 2. So overall, this is equals to 2. So that's all we have to answer. All right, that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you're on your way out. I will catch you all in the next lesson. Signing out.